All right. Everybody say hi, Keaton, TJ, and Kelsey.
Hi, TJ, Kelsey.
They don't like you very much. Okay. We are at, this is section notes for 3-1, and we are at the bottom of the second page. There's one more thing that I want to talk about before we move on to the third. Shh. You boys got to be quiet, or MJ, you get moved. Back. All right. Round off rules. This is telling us how to round, okay? You people who are trained with Mr. Moose class, like Sig Figs, okay? Here is the rounding rules for when we're doing things, okay? For the mean, the median, and the mid-range, anytime you're doing any calculations, you do one more decimal place than they all have already. So if we have whole numbers like 1 and 3 and 7 and 11 and 14, and we're trying to find the average, we would round to the nearest this point, this, one decimal place, right? That's how we would round if we have just whole numbers, okay? If we have decimals like 1.1 and 3.7 and 4.5 and 8.9 and ... we would round to this number point ... two decimal places. Does that make sense? Because these each have one decimal place. So we're going to round to 2 decimal places when we find the average, right? That's the rounding rules, okay? For the mode, why do they say for the mode you leave it without rounding? The mode, you don't have to do any calculations, right? It's just the mode, the one that occurs the most. You just leave it the same as what it is in the data set, right? So the mode is exempt from that. But mean, median, now median, you only have to do like one more decimal place if you're having the average of the two middle numbers, right? If it has an exact middle number, you just do that exact middle number, right? But the median, if you have two numbers that you have to average together, that's when you do this, okay? Mid-range, same thing, okay? So rounding rules, one more decimal place. On the homework assignment, if you don't follow these rules, it will flag it and say that it's wrong, and you'll be like, what? Okay? So make sure you are going off of these rules. That's the rules, okay? Example 6. Here you go. They are saying, it says right here, see each of the following illustrations in which the mean and the median are not meaningful. Okay? So there is a time and a place for finding the average, and there's a time and a place for finding the middle number, and each of these does not make sense. Does it make sense to find the average zip code?
Yeah. No.
Why not?
Because it's too many numbers.
Because that's not what it's saying. They're not.
They're all like a specific number, okay? They are like
It's not counting.
categorical, right?
Yeah, category.
Aren't zip codes categorical?
Yeah.
It's like categorical data. It doesn't make any sense to take the median or the average of categories, right? Okay. What about ranks of selected national universities? Like Harvard is ranking number 2, and Yale is number 3, and Duke is number 4, and whatever.
No.
Right? Why not? Why doesn't it make sense to do?
Still the order in the categories.
We're still doing categories, right? Like first place, second place, third place. You wouldn't say they rank place number 3.75. That doesn't make any sense, right? So those are still categorical data. What about numbers on jerseys? That's part C. Why would not it?
Still, because it's literally
It's
like a name.
still another category, right? You wouldn't say MJ wears the jersey number 33.2, right? That doesn't make any sense. Very cute. I like it. Yeah. Okay. So all of these are categories. Okay. Now the next one.
Yale's gone too.
The next one is not what? Oh yeah. The next one is not a category. It says the top 5 incomes. Okay, pay attention to this very carefully. Top 5 incomes of the CEOs of massive corporations. Why would it not make sense for me to say the average of their salaries? Like I could say the average salary for a top 5 CEO is blah, 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 right? Okay. But they say this list includes data that are not at all representatives of the larger population, right? That's just the average of the top 5 CEOs. Great. We can't relate that to all CEOs. So that number's not really doing anything extra for me. I could find the average and it might even make sense, right? But the top 5 CEOs, their average is going to not be the same as all CEOs. So it's not really doing a whole lot for me, okay? So, does not represent a larger population.
Nope.
The top 5 is not going to be the same as any of the other CEOs in any other company, right? Okay, so that doesn't do anything for me. And then the last example says the 50 mean ages computed from the means in each of the 50 states. So we're doing the average of all of the ages of each 50 states. Okay? Why would that not be good? We can do average age, and that might even make sense. This is kind of for the same way that we don't have the same number of representatives as like Texas does. Why is that? Population size. Maybe all of the retired people leave Nebraska and go to Texas. Okay, so maybe there's a lot of old people in Texas because that's where they're retiring to. So their mean age might not be the same as our mean age, but population is different, okay? So differing population sizes. Okay, that will throw off, and we can't just weight them evenly. We can't just take the average of Texas, the average of Nebraska, the average of Kansas, the average of Hawaii, right? They're all going to be weighted differently because Texas is larger. California is larger. New York has a larger population, okay, because they're more densely populated. So those things we have to take into consideration when we're dealing with those groupings, right? Okay, part 2, beyond the basics, measures of centers. Okay, we're talking about frequency distribution. Circle that. Okay, you're going to get to the homework assignment and you're going to be like, how do I do this? Here's how you do this. Ready? They're going to give you a frequency table right here. This is what they will give to you, and they will say, find the average. Okay? Now, one of the problems that we've encountered before with a frequency table is that I only know that there are 11 numbers in this chunk, but I don't know what each one of those 11 numbers are. Maybe every single one of those numbers is 121. I have no idea, right? I don't know what the individual numbers are. So how do I find the average when I don't know each of the individual numbers? You find the midpoint. Okay, so here we go. We're finding the midpoint. So they've done another column, and they're saying exactly the middle of 75 to 124 is 99.5. How did they find that? 75, they're finding the average. 75 plus 124 divided by 2 gives you that number. If you need to write some work in there, that's how you find that. That is the midpoint. No. Mid-range would be like the range of the whole thing. Yeah. So the mid-range is kind of like finding the midpoint for the entire data set, but this is like a bunch of mid-ranges. Sure. Yeah, okay. If that helps you. Yes. Sure.
It helps me.
Sure, go for it. Okay, so the midpoint of each one of these classes is these numbers right here. Okay? All right, good. And then what we're going to do is we are going to take 11 times 99.5. And that is this number right here because there are 11 of those numbers, right? There are 11 of them. We take 24 times 149.5 and we get this number, right? We're multiplying the number of numbers times the midpoint, right? The number of numbers times the midpoint. And then what do? Add all of these up right here, okay, which they've done for us is 8,025. But is that the average? 8,025 seconds for me to get my meal? That's all of them added together, but then we have to divide by 50 because there's 50 people, right, that we're doing, okay? So just to recap, before we divide that out, there are 11 in the first category, 24 in the second category, but we can't do a range, so we do the midpoint. 11 times 99.5, 24 times 149.5, 10 times 199.5, etc. Add all those up, but then we still have to divide by 50. Does somebody have that number? On average, how many seconds is it going to take me to get my meal? 160.5 seconds is the average. Okay, so when you're doing a frequency table, you have to do the midpoint. Use midpoint to find the average. Okay, for a frequency table. You can't use a range. You have to use the midpoint times the frequency and then add them all together and divide by the frequency. Does this make sense? Yeah. That's the only option you have. Okay, last example is a weighted mean, okay? Weighted, what does it mean for something to be weighted? Yeah, like your grade in this class is weighted. Did you know that? Yeah. You guys are different than any others because we don't do quizzes in here. So your homework is 25% of your grade. Write this down at the top of the paper. Your homework is 25% of your grade. Any projects that we do, like the packets that I give to you, like the graphing things, those are also 25% because those are kind of like homework assignments. But sometimes we do them together. And then you have the last chunk, which is the test. And that accounts for 50% of your grade. Okay, so let's do an example here. Let's say all of your homework grades average together, right? Your average homework grade. Average homework grade is a 92. Okay, let's say your average homework grade. That's the average of all of the homework grades together, okay? The average project grade that you have out of like the 3 packets that we've done, let's say that that's a 95, right? Okay, and we have had 2 tests, and the average of those 2 tests, let's say, is an 87. Okay, all right? So how would your total average be calculated? Or your total?
All of the.
Take them times, like, 87 times 12.
So you would take 92, which is your first grade, and you would multiply that by 0.25. And you would add that to 95 is the next category, and you would multiply that by
Yeah, that's what.
0.25. And then you would add 87, and you would multiply that by 0.5, right? Okay? But then what do we divide by? You kind of do-ish. What does 0.25 and 0.25 and 0.5 add up to be? 100%, which is just 1. So you're really dividing by 1, which really you're not dividing by anything because it's, dividing by 1 is not doing anything, okay? So if we do that, I don't know. Does somebody do that for me? Mads is on top of it. Okay. Do we want, hold on, before she gives us the answer, do we want to take a stab at what the average will be?
No.
It's going to be closest to what?
92.
You think it's going to be closest to 92? I think this 87's pulling the most weight. It's going to pull you down really hard.
90.
Maybe it's just gonna be like 90, 91.
90.
I'm going to guess about 90, 91. Yeah, that's what I'm going to say. Even though you've got that 95 in there, woohoo, the 87 has the most weight. It's going to pull you down, right?
90.2.
That's why you have people that have like
Wow.
99s in homework and then they drop a 70 in for a test and they're like, why is my grade so low, right?
90.
It's because your test is low, right?
90.
What is it?
90.25.
90.25. So a 90% basically is what your entire grade will be. Even though you've got that 95 and that 92 in there, the 87's pulling you down, right? Okay, so that's how a weighted average works, okay? You take this is the formula for it. This means sum, which means you're adding them all together, but you're doing the weight times the value, okay? Weight times value. So the first one, my weight was 0.25, the value was 92, okay? And then I divide by the total weight. Right? Divide by the total weight. Did we divide by the total weight up here? Technically, because the total weight was 1, right? Okay? So that's what that formula kind of represents. The sum of all the weights times the value. Weight times value. Weight times value. Weight times value. Add them all together and divide by the total weights. Okay? This next example is going to be a little bit confusing because they use A, B, C, D to represent this, okay? So, here we go. It's not terribly confusing, but you got to kind of listen, okay? So, in her first semester of college, a student of the author of this book, evidently, took 5 courses. Her final grades, along with the number of credits for each course, were, she got an A, and that was worth 3 credits, okay? So she got an A in a 3-credit course, okay? She got another A in a 4-credit course. She got a B in a 3-credit course. She got a C in a 3-credit course. And she got an F in a 1-credit course. Do you see where I'm getting these numbers from? A in 3 credits, A in 4, or B in 3, C in 3, F in 1, right? Do you know how in college they do credits and stuff? How does credits work? Like, what does that even mean? How many credits do you guys get for being in this class for stats? 3, right? You'll end up with 3 credits, okay? Most normal classes that you attend, like Monday, Wednesday, Friday, like a normal class would be 3 credits. When is it 4 credits?
Lab.
usually if you have a lab with it, okay? So it's like a 4-day-a-week class, okay? 2 credit classes might be like just a Tuesday, Thursday class. A 1 credit class is just going to be like every Monday I go to this class. And usually those are like most colleges will have like a freshman level class like you go to, and then you're just like checking into that class to say like, are you keeping up on your studies and learning things and whatever, just acclimating to the college life. You'll have like a freshman entry class. That will be like 1 credit. Whoop. And basically those 1 credit classes are kind of like PUD classes because all you have to do is show up basically. So what's happening here? She's not going to class, right? Probably is what's happening here. So anyway, that's how that works, okay? So we have this, okay? And what we did above when we had like an 87% in 50% and we had a 92 for a 25%, we multiplied these together, right? But how do you multiply an A times 3? Right? So we use the scale that they gave right here. This says an A is equivalent to 4, B is 3, C is 2, D is 1, F is 0, right? Okay? So this is how this works. Instead of using A, we're going to use a 4, right? Because we can't take A times a number. This A is also doing 4. This B is doing 3, this C is doing 2, and the F is doing 0. We don't have a D in there. Okay, good? All right, so we would do 4 times 4. Actually, let's just do this. Let's just do this. We'll just go across here. Equals, 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 equals. And we'll add them up. Okay? 4 times 3 is 12, right? She's getting like 12 points for that first class, okay? 4 times 4, she's getting 16 points for that second class, okay? 3 times 3 is 9. 2 times 3, 6. 0 times 1. She's getting no points for not going to that class, basically, okay? If we add all of those up, this is 28, this is 15. 28 plus 15 is 43. Somebody check me on that, check my math. 43, okay? All right, but we have to divide that 43 by something. Now, here's where everybody gets tripped up, okay? Do we divide by this total number?
Yeah.
Or do we divide by this total number?
That's one number.
Which one?
The one on the left.
Are you sure?
No, 14 credits.
No, why? You tell me I'm wrong. I'm probably gonna cry.
Which one's gonna stay the same? Like if I would get a different grade.
Oh yeah, on the right.
This right one is gonna stay the same regardless of how I score, right? This number stays the same, right? Like if I got an F in each one of these, it would be zeros all the way across, but I still have to divide by the number of credits that I have, right? This is how much it's worth, right? Okay? Like the 0.25, 0.25, 0.5, that's how much it was worth before, right? That's how much your 92 and your 95 and your 87 were worth. We divide by the worth. This is the worth of it. That's what each thing is worth. So we divide by those. 3, 4, 3, 3, and 1
14.
would be 14. So we're taking 43, dividing by 14. That's where that comes from, okay? 43 divided by 14, she got a what? I don't know. 3 point what? 3.07. Okay. So what does that translate into? On average, she is a B student, right? A 3 is a B, right? A 4 is an A, etc. Okay. So she is a B, like a B minus almost student probably. Okay. That's what she is. Does that make sense? Okay. But the confusing part of that, it's not hard, but the confusing part is that you're going to divide by the credits. You're not dividing by the A, B, C's, and D's, right? Because these, if you get a different grade, will change, right? If you get a different grade, those numbers will change, and then you're going to be dividing by a different number. Here, you're wanting to divide by the credits. Those will stay the same. Does that make sense?
So we're dividing by the credits.
You're dividing by the credits, right? Like up here, when we did this one, this is the credits, right? That's what we're dividing by, the 0.25, the 0.25, the 0.5, that's what we're dividing by, which totals out to be 1. That's how much the categories are credited, okay? Make sense? Mm-hmm. That's not hard, right? But if you do the wrong thing, then you're just going to get the wrong answer, okay? All right? Happy with that? Mm-hmm. Homework assignment is posted online. It takes a bit of time, so you might want to start. That would be a really good idea. Okay, everybody say bye, people who are watching this video.